Ignition sequence start. 3, 2, 1.
Houston, we have a problem.
Liftoff. We have a liftoff.
We copy you on the ground. You got a bunch of guys about to turn blue.
What you're seeing here is a mirage.
Are you ready?
Debate fans,
Are you ready?
for the handful in attendance and the thousands watching across the world, brought to you tonight by Jeranism, the #1 YouTube channel in all of existence. Ladies and gentlemen,
Let's get ready to rumble!
Make sure your argument is tight. Babe, what? You must got proof if you so right. Babe, what? Don't get dismissed on false claims because you gotta bring the truths in the facts. It don't matter if you're talking about racism, sexism, scientism, paganism, socialism, communism. Talk about capitalism, atheism, globalism. What about creationism? It don't matter what it is. I'm live on Debatism.
Welcome, everybody, to another episode of Debatism. We got Debatism X tonight and a barn burner for sure. We've got Alan from Space Audits going against Lucas Sealion Prime is QED a physically correct interpretation of reality, or is it not? Let me bring the guys on. We'll get you going. Here we go. First up, we've got Lucas over here. Lucas, say hello to everybody and tell them who you are.
Hey, I'm Lucas, also known as Sealion Prime or Mordwand. Run a little server called Globe Gangsters and enjoy debating and discussing ideas in cosmology, physics, shape of the Earth, all those fun topics as well as others. Looking forward to tonight's debate.
Beautiful. And we've also got Alan from Space Audits. Alan, what's up?
Hola, senor.
Hola.
I'm here representing Ether Cosmology. We'll be debating tonight on quantum electrodynamics, and is it the correct interpretation of reality, or is the classical version still viable? So we'll be discussing some experiments and different aspects of them that are supposed to provide mutual exclusivity of one model over the other, and it should be pretty fun.
Excellent. And you want to tell us about the format that you've chosen?
Yeah, so we'll both be presenting 3 claims, and there'll be a 2-minute cross-examination after the claims. To provide evidence for your claim, you have 3 minutes. So it'll kind of be like speed rounds, and then the cross-examination, and then 1-minute outros. It'd be about 30 minutes in total.
Okay, beautiful. And we're doing no intros, is that correct?
I think that's on the thing.
Oh, we have. Round one. We're just going right into round one. 3 minutes for the opponent to present his topic. Is that correct?
Yeah. Is there anything you wanted to say more before we begin, and do you want to flip for who goes first?
Yeah, I mean, since I'm doing the affirmation, I can go first, or unless you have a preference, Alan.
No, yeah, you can take the first for the affirmation.
Okay.
Okay, so Lucas is going to be going first, and no intro, just straight into the proof of null, right?
Okay.
Sounds good.
Yeah, just into the statement of my position, and then quickly I'll just talk through the.
Sounds good.
Talk through the first claim. So
okay. When you're ready, I'll start your clock.
My screen, and you're ready to go.
Did you say you're going to be sharing screen? I'm sorry, I didn't hear you.
Yeah, I just did.
Okay. And I do see it. Let me see here if we've got this one right. Okay, and I believe we're good there. Yep. Whenever you want to start, go ahead.
All right. My position is that QED, or quantum electrodynamics, is a physically correct and consistent model of reality, and I will be presenting that in 3 primary contentions. The first of which is essentially, why did we develop QED, or the royal we, as they say, but why did physicists develop QED and quantum mechanics and the associated frameworks? The answer, simply speaking, is not because they wanted to. And the first contention is, in fact, they did not want to. They avoided acquiescing to the reality of the experiments until it was no longer tenable to do so. There's a few quotes that I think are extremely illustrative of the mindset of the classical sort of theorists of the state of physics going into the 1920s as it relates to classical versus quantum mechanics. There's a couple slides here, or images here, that just show some models related to that. But I really want to focus on these quotes. So the first one is by Wolfgang Pauli, who says, "How can one look happy when he's thinking of the anomalous Zeeman effect?" Dramatic physicist here. And Otto Stern, who is one of the authors of the Stirling-Gerlach experiment, actually said, "If this nonsense," meaning the quantum model, "of Bohr should in the end prove to be right, we will quit physics." So the motivation was to preserve classical physics. The motivation was to have a deterministic and classical view of the world. It could not be done. And the primary arbiter of the decline of the classical theory was the landmark Stern-Gerlach experiment. This slide shows you two things that I want to draw your attention to. The first is the level of precision that we're talking about in these experiments. So what you're seeing here is on the left, the deposition of silver atoms without a magnetic field, and then on the right, the deposition pattern of those same beam of silver atoms when they go through an inhomogeneous magnetic field. Notice that the 1 millimeter scale is indicated. So this was an extremely precise experiment for its time. And the fact that it's split into two indicates quantization, meaning it was not a continuous distribution. And indeed, the development of quantum electrodynamics, which was the extension of quantum mechanics to light and matter, itself is a mechanistic explanation, describing the activities of the parts of a system and a causal mechanism for that to occur. Now, from this paper that I have referenced here, a mechanistic explanation proceeds to what is basically a fundamental or bottom level. And it's going to then define a model, which will then be an idealized representation of the real world system. So all of the research and all of the literature would suggest that the method by which Feynman derived QED was mechanistic. And what you can see here is the levels of development that were done here and the role that the Feynman diagram, which is a graphical illustration of the model, served to illustrate that mechanistic explanation, which at the bottom level has the propagation of a particle, quanta, from space-time point to space-time point. And that is the mechanistic foundation that we will be discussing today of QED. And I yield my time to Alan.
Okay. Alan, 2 minutes.
Okay. So looking at the Feynman diagram, starting with that, Feynman couldn't define or couldn't explain how his diagrams and equations were a consequence of Dirac's field equations. He was asked in the in the 30s or 40s at the Soive meeting to explain this situation, and he couldn't provide any explanation that links his diagrams to a consequence of Dirac's field equations. And that led to a history of fraud where the free parameters and coefficients were adjusted to, make agreement with his diagrams. Are you aware of that history?
Well, I push back on the characterization of it being fraudulent. Well, what is your basis for that statement? I mean,
specifically Karplus and Kroll, who hinged their calculations on the Feynman diagram, solving a set of 7 of them, and they hinged all these solutions that they give. None of them really matter. The big value that they got was from diagram 2C, and they've never substantiated how they actually calculated that. At the end of their paper, they go on to say that they'll explain how they did it in a following paper, and they never could. They never substantiated it at all. And then later on, that they admitted that they got together and made both of their papers agree with one another. And they had previously said that they had independently derived these solutions, but they collaborated together. And they admitted to it, and Feynman talks about that in his memoirs. And he's like, "Oh, well, you know what they say. Sometimes you just do a little fraud." That's not a direct quote, but
Well, I would appreciate keeping it to direct quotes, but I don't really see evidence of fraud here. And moreover, I don't really see an extension of fraud to the construction of the mechanistic theory. I see that there was perhaps some level of impropriety in 2 authors developing a particular variation of this theory, but I don't see how your conclusion follows from your premises at all there.
Well, if I made a claim that I independently derived a solution and that my friend also independently derived a solution that corroborates the correctness of our derivations, and we said that this, we didn't cross-reference each other, we didn't collude together, and then it turned out that we did, and I admitted it 7 years later, 7 months before we were about to be experimentally overthrown in the experimental measurement, and then they would have to bring in new coefficients and adjustments to further substantiate the correctness of the diagrams that were originally built on us lying together. That's fraud and collusion.
Well, yeah, but addressing this specific point. So what I've presented here is the mechanistic construction using the Feynman diagrams of quantum electrodynamics, and it seems like a few things are being conflated here. I mean, there's renormalization, which I'll certainly get into, which I think you referenced. But there's this specific case, which I think pertains to, correct me if I'm wrong, but this pertains to the measurement or prediction of the anomalous magnetic moment of the electron, or the so-called G factor, the K&K paper that you're referring to.
Yes.
Oh, looks like you're up. Oh, okay. So to me, I mean, it would strike me that it's odd that the entire theory would be associated with the actions of two individuals writing a particular paper. And we can certainly get into the physical validity of more recent measurements of the G factor and theoretical papers thereof. But I guess I'm missing how the mechanistic construction of the theory would be in any way tarnished by the actions of these two individuals, even assuming that the record stands as you describe it.
Got you. So let's see here.
But I think we're over the 2-minute CE. So how do we want to move from here?
Looks like Alan should then present, right?
Yeah, we should move on. Okay.
Okay, you got 3 minutes.
Give me 1 second. Can you stop screen sharing for a sec?
Oh yeah, sorry about that.
Yep, no worries. Did that share the correct thing?
I don't see anything yet.
Desktop capture. No, not working. Give me 1 sec.
No problem. If you guys have any questions for the guys, you can send in super chats or Rokfin tips. We'll get to those at the end.
All right. Well, the beginning of this, the intro, or my first thing doesn't really require any visuals anyway.
Okay.
I'll just go ahead and send it. But I was gonna have stuff to present for the second stuff. But anyway, okay. So go ahead and start my clock.
Take it.
Okay, so why is quantum electrodynamics physically wrong? As we were just kind of previously touching on, the equations that Dirac came up with to describe the discrete packets of the electromagnetic field and the interactions that would lead to the magnetic moment of the electron, etc., were actually off on their experimentally predicted values, and that's when Schwinger came in and introduced his Schwinger factor to explain this, and he couldn't explain how he derived his coefficient to fix things. And Feynman also, right after that, proposed his Feynman diagrams and equations on how he could explain these effects. And neither of these people could explain how they were consequences of Dirac's equations or how they related. They were just simply linked by the experimental. Like you can make the result give the same value as the experiment that was given. So Feynman famously said, I'd rather have questions that can't be answered than answers that can't be questioned. Yet he couldn't, when people at the Soive conference where he was presenting this were questioning him on how his equations were a consequence of Dirac's field equations, he couldn't answer that. So all they've done is brought in another explanatory framework to backwards support what was experimentally falsified with measurement, and then they were like, oh look, this is the prediction of our measurement. And then to build upon that, we had the case with Karplus and Kroll where they said that they had independently derived the solutions and everything was backed up on Feynman diagram 2C, which gave the biggest value for adding up all the other diagrams. So obviously it was the most important one, and that was the one that they specifically didn't show how either of them derived it. And then they went on later to admit to the fraud, and they even, like I said, Feynman even talks about it in his diagram or in his memoirs. And with that, and then after that, they were experimentally falsified. So it wasn't even possible for them to have come to that conclusion as a natural consequence, unless they made the equations give agreement with what was established at the time as the physically correct answer to give. So there's other problems with QED that make it physically incorrect, such as Dirac stating that it starts with a physically uncharged electron. And the problem with the mathematics is that when they make the uncharged electron interact with the quantized field to give it charge, then they have to introduce perturbation theory. And as a result of that, the mass changes from the uncharged electron to the charged electron, which leads to them having to account for renormalizations. And that basically means that their equations are physically meaningless because they diverge to infinity and never reconverge. How much time do I have?
Time right there.
Yeah.
Just ran out. Okay, 2 minutes, Lucas.
Yeah, so there's a lot to dive into there, but I think I really want to get into this allegation of fraud. So is your contention that K and K acted fraudulently, or that the entire theory is fraudulent?
Well, everybody really needed a solution to why Dirac's equations didn't meet experimental prediction. So it was out of necessity to keep the theory, to keep, the idea that the field is made up of discrete packets that aren't physically connected by anything, and you could describe it through abstract mathematics.
Sure, but that doesn't quite answer, like, yes or no. Is it a one case, or does that apply to everyone working in the space?
Well, let's see. None of them could ever answer how what they were presenting was a consequence of Dirac's equations. So whether or not they were in on some sort of fraud, what they were allowed to get away with was whatever everyone else would accept. And everyone, started accepting Feynman's diagrams based on the credibility of Karplus and Krull. So they really, in specific, kicked it off together. And then subsequent people had to, introduce theories to explain it as they came up with new measurements that disproved the old coefficients and everything that were used.
So, but that doesn't imply that everyone was sort of colluding or being fraudulent in any way, right? It seems to me that your main criticism is post-diction. Is that fair?
Oh, absolutely. The fact that it's not a physically correct interpretation of reality. They have mathematics that will fit the measurement post-diction and then act like it was a prediction the whole time. That was what Karplus and Krull did. That's what that's what they've all been doing.
Okay, so perhaps the issue would be better stated as, there might have been some impropriety with K and K, but perhaps we better state that post-diction is really the issue and not fraud. I would posit that as a less charged way to have the discussion in good faith. But the best thing that I would say is, can you reference any divergence from predictions of quantum electrodynamics that has happened in the last 30 years?
Yeah, Lamb shift and the 7 times that they readjusted the coefficients that they used to do the renormalizations, which are basically adjustments so that they'll fit experimental measurement.
Can you give a specific citation?
Give me 1 second. So the Lamb shift experiment, right? The predicted amount for hydrogen, the predicted amount of energy or whatever was off. So your boy Beta came in and introduced a divergent series that he just couldn't explain how it came to be. He was actually supposed to write a paper following up on how he why he introduced his K series, and that didn't come up. And then also there was Schwinger, who was explaining the exact same thing, introducing his coefficient, and he couldn't explain it either. There was, let's see, who are these other lads? We got.
Yeah, but I'm saying within the last.
There's more. There's more.
Yeah.
Hold on, I'm still
we're up on the CE time, so I don't know if we want to take these CEs longer or if we just want to keep it to 2 minutes.
Well, you have 2 minutes, but you're asking questions, so I don't know if you want.
Oh, okay, I got it. Sorry, I didn't see the timer was going down.
Yeah. So okay, I just been stopping the clock when you are asking him a question.
Okay, my bad.
So Karplus and Krull was in the 50s. Let's see, there was 56. Franken and Lebanese, they measured a new value, and let's see, their value disproved Karplus and Kroll, but then a month, or okay, so they had a prediction, right? They came out with their prediction that was going to falsify Karplus and Kroll, and then a month later they measured the experience that they, said that they confirmed that measurement was correct, and then that's when Karplus and Kroll, admitted that they were cooking the books on diagram 2.
Oh wait, could I just stop you there for 1 second? You mentioned a prediction that was made.
Yeah, they said that they had a prediction that was going to supplant Karplus and Kroll, and then they, measured it, and that gave agreement or whatever, and they were good to go. And then that was superseded later by a guy named Peterman when he realized that the 2C diagram was fraudulent as well. So he came up with another prediction, and let's see, that was. Then there was Ternative and Remedy in 1972, and then Schwinger again in 1989, where they started using Green's functions.
I see.
So yeah, sorry, I can't share my screen, but I got the list up here.
No problem. But I just think it's interesting that you had characterized everything as post-dictive, yet you had mentioned predictions that had met. Had been sort of borne out by experiments. Can you clarify that contradiction for me?
No contradiction. It's following the behavior of them adjusting the math to make it fit the prediction. Now, their values that they derived gave, agreement with what they, measured a month later, and then that was later superseded by another person, and then his stuff was superseded by another person. So it's just a continuation of people deriving something that they think gives a good agreement at the time, and then it's all good because like I said, they're just doing renormalizations. So when you have that level of freedom, you can make the output whatever you need it to be. So that's what they're doing, and they're calling it predictions and whatnot. But then they just falsify it years later.
But if they falsify it, would that be a post-diction or a prediction? I'm just not seeing the issue here. So surely the theory evolves over time, but you've listed multiple examples where predictions were made and then the prediction was either falsified or accepted, correct?
Well, that was the one time, right? Every time after now is just adjustments to the coefficients. So after the guy that falsified the new values for the Karplus and Kroll, that was every time after that, they just adjust coefficients to meet the measurements now. So they don't make predictions.
Final thought here, Lucas, because that's your time's up. So just go ahead and make your last statement here.
Okay, no further questions. Thank you.
Yeah, we're good.
Okay. Alan, you want to go ahead? 2 minutes.
I just went. It's his turn now.
Yep.
To present his next piece.
Okay.
I'm going to try to just share the deck so it's easier to see, but it might not work. Are you seeing it?
Yep.
Yeah, we see it.
So key contention here is going to be whether QED is representative of physical reality or not. In my prior point, I had demonstrated that it was a mechanistic explanation built up and models are mere representations of reality. I will posit that our criteria for evaluating QED should be that of Feynman himself, which said, no matter how beautiful your theory is, no matter how smart you are, if it doesn't agree with the experiment, it's wrong. Within this context, I'm not going to focus on this slide too much, but just to give you a sense of some particular aspects of quantum theory that are extremely well validated. There's 2 quotes here that are relevant. One from a recent photonics paper, which says that the legitimacy and requirement of the photon concept in optics is never in doubt, and QED is the only theory in which it is completely valid. And a second quote by the discoverer of nuclear magnetic resonance, which is the basis for all MRI imaging, which states that after Stern-Gerlach, we had to face the fact that quantum phenomena required a completely new orientation. Now, if we're going to look at what the basis of a quantum field theory is, I'm presenting here that matter and force measure as quantized fields with exhibited duality. That's demonstrated by recent experiments in spatial and time variable diffraction, which show the wave-like behavior, but as well as extensive experimentation in Compton scattering, demonstrating momentum of photons and particle behavior. The key thing here, and I'm not sure why we're stuck in the 50s, is that experiments have confirmed QED's predictions over and over again. It is by far the most precise theory in all of science. So the accusation of a post-diction to me seems completely off. On the left-hand side, I have a long list of things that have been experimentally predicted ahead of time and predicted. One of the most important being the Casimir effect, which was a predicted phenomenon not observed till much, much later, and that was validated. Most recently, we've had a theoretical prediction of the so-called G factor that was made predictively and then verified to a measurement error of, you can see the tiny percentage there, is an extremely precise theory. I think what it really comes down to, whether it is a prediction or a post-diction, is whether renormalization is physical or not, or whether it's just manipulating the theory to be post-dictive. It's telling, I think, though, that we haven't brought up in our discussion a mention of Ken Wilson. I would like to bring this discussion into the fold of the later half of the 20th century, in which, as this paper noted, Ken Wilson made renormalization physics by uncovering its connections to scale transformations. And that's exactly what you see on the left. All of the mathematics that Alan is describing are related to the self-similarity properties of scale within quantum systems and quantum fields. And that is the basis of renormalization. And that is a physically valid and mathematically valid basis, as was shown by the work of Ken Wilson.
Time, great. Alan, 2 minutes.
So for Compton scattering, would you say that in the equation that they give, like the final formalization, I don't know if you showed it there, but would you say that the H over MC is implying the massless particle, relationship where light is just a discrete packet of energy?
Well, I think that to my knowledge, we haven't measured because of the relationship between Coulomb's law and the rest mass of the photon, our lack of any invalidation of Coulomb's law suggests that there isn't a rest mass of the photon. Is that what you're asking? And how does that relate to Compton scattering? I'm not sure I quite get the question.
Well, the rest mass of the photon is an idealized calculation. There's nothing that's at rest. It just creates an artificial deficit in the kinetic energy for the photon or whatever when it interacts. But the question specifically was in the final formalization of the equation for Compton scattering, there's a component in there that's H over MC, which is tying the massless particle. It's allowing them to derive momentum as a function of the photon's energy rather than the wavelength. So because if it's a wave, it would require a medium, but they're saying that light, has no mass. It doesn't require a medium wave particle duality. It has to be a discrete quantized chunk. And that's represented in the equation as H over MC. Would you agree?
I don't agree that a electromagnetic wave requires a medium, but I do see what you're talking about. I'm just curious. So you're referring to the angle equation or the energy equation? Like which equation?
The angle equation.
The angle equation?
Yeah, I'll send you a screenshot real quick on.
Yeah, no, I see it here. So, okay. I see the, you're talking about the H over ME times C?
Yep.
Well, yeah, but surely that's the rest mass of the electron, not of the photon, right?
No, I got you. But the H, right, is specifically in reference to the energy of the photon because Planck's constant only applies to electromagnetic radiation. So what they're saying is like the ratio of change, with respect to that rest mass or whatever.
Sure, but I don't really see this as being an issue either. Are you saying that this invalidates Compton scattering and things that are derived based on Compton scattering, or what are you getting at with this question?
I'm asking if you agree that photons are discrete packets of energy represented by Planck's constant, and that is what allows them to have momentum, even though they don't have mass.
I think that there are two representations of photons, as I presented, that are equally valid as a function of context, and we can demonstrate that it obeys both of those properties. Recent experiments have, consistently shown the time varying and spatial varying diffraction, indicating wave-like behavior. And then we have experiments such as Compton scattering, which is extremely well substantiated, that show particle behavior. That's also true of
Yeah.
what we consider particles with mass as well.
So you agree that the interpretation of this is that this is the quantization of light, right?
Correct. Yes.
Gotcha. Okay, cool. Just wanted to clear that up. So okay, we're out of time now for the other stuff, but okay. So I'm going to send you this because you can't see it, but I'm going to walk you through it, and I have it up on my screen so people could see it, but I'm not able to screen share on here for some reason.
So now we're going to 3 minutes, right?
Technical difficulty on my part. Yep.
Okay. Where are you sending it to me?
On Discord.
Okay, hold up. I don't have Discord open. Let me open it for real quick.
Yep.
Oh, of course it decides to update. Let me pull it up on my phone. I'm sorry about that.
Yeah, they got to get you with the Halloween update, brother.
Sure,
of course. Okay, cool. So I see a handwritten equation of Compton scattering, and then MC, where M is the rest mass of the electron.
Yep. So what we're going to do is we're going to cancel out this rest mass, and we're going to look at this through the way that you would conserve momentum through a wave. So starting with delta lambda equals delta prime minus delta, or lambda equals h over mc times the cosine, or times 1 minus the cosine theta. That's what's going to give us our prediction right there. So over here on the left, we have the physical momentum side of things, right? So P equals mv times mc, h over mc, and then we could rewrite that as h over p. And then on the right of that, we have the energy equation for momentum. So P equals E over V, and then we can reduce that down to E over C because we're talking about electromagnetic propagation, so the speed of light. So we have the velocity for V. We could further break down the physical part of it now to H over P is equal to H times C over E. And then because we're talking about light here, we can take C, turn it into lambda times F, which is lambda times the frequency. That's going to give you the speed of light. So then we have H times C over E equals H times F lambda, which is basically showing that the proportional ratio of F that's substituted in for the lambda in the equation when you do like E equals H nu, which is just Planck's constant times the frequency, right? So we're going to start over energy. We're going to start reducing this down. We're going to get rid of the excess energy amounts, right? So Planck's constant is energy. Anytime you see H, you can think energy. So now we're reducing that down. H times F equals E. So we can rewrite this as HF lambda over E, and then E lambda over E. We can reduce all the excess energy out of that to just lambda. So we can make the prediction with just delta lambda equals the changed wavelength minus the original wavelength is equal to the starting wavelength times the cosine angle. So this isn't a mutually exclusive prediction to quantum theory. This is just looking at it through the lens of wave particle duality, where light has to be a quantized chunk of energy. So they're describing it through the energy momentum, like as the physical part. But you can rewrite this as through the wave equation, and there's no issue. It makes the correct prediction, and the energy is conserved as a function of the change in the wavelength with respect to the angle.
Okay, good. You got 2 minutes, Mordor.
Okay, cool. So what is the citation for this? Or is this original work that you've done?
Yeah, so I know we swap citations, but there's in the Chang paper that I gave you, he gets into the derivation for Compton scattering, and that's where this is from. Now, what you can do with the reduced formalization, there's with reducing it down to that, that's just algebraic shuffling. If they can shuffle it in, and because they started with E over C, or P equals E over C, it's just as valid to restart it and not swap out the Planck's constant, because it just represents energy at the end of the day, which is proportional to the wavelength, which times the frequency gives you the correct output anyway. So it's not necessary for you to view it in that manner. And you could go, there's a website I can link you. It's a physics form or whatever textbook thing they show the final derivation from Compton, which gives the familiar equation with H over MC, and then they give the bottom final form that I put, but they don't show you how they got there. But this is how they would have got there. This is how you would do it with just the wave energy, and you would cancel out Planck's constant instead of keeping it in, because the form they show you isn't the final form that it could be if you just do it through through as a wave, and then you don't have to invoke a rest mass of an electron that doesn't exist.
Well, that's a bit odd because in what sense doesn't the rest mass of an electron exist?
Nothing's at rest. It would have to be at absolute zero, right? It's just an idealized calculation. Everything's vibrating and oscillating. The electron's in an orbit. It has binding energy. It's stuck to the nuclear structure of its, atom. So they're not at rest. It's just to create an artificial deficit.
So there we have it again. So I'm curious though here. So what is the actual experimental evidence that removing the applicate, because all the sources that I've presented suggest that the photon is required in this sort of, and I'll present more evidence to that effect in practical engineering. What experiments have actually been done to validate this mode of transmission that is modeled with a wave rather than a particle?
Well, none. They don't even take a wavelength measurement on the apparatus. All they do is ionize the energy output from it, and it's supposed to give a specific amount that they've calibrated to, which gives the agreement that it would give the corresponding wavelength change. But because it would give the corresponding wavelength change, Planck's constant is representative of that proportional aspect of the wavelength. So it's just as valid to cancel it out and not even look at it that way as a ballistic projectile with no mass. Okay, but you realize, right, that both of these, as per what I had described, are simply models that describe the effect, right? Well, we're debating on the physical correctness of the models, and quantum electrodynamics is physically supported, or not physically, it's physically supported by the idea that light is quantized chunks of energy and not a wave. They specifically teach that the wave aspect is the abstract part of quantum mechanics, and the physical part is the ballistic projectile, the quantized energy part, represented by Planck's constant, which is equivalent to the wavelength. Well, that's what a PhD said in a YouTube video on when she did the double slit experiment. But doesn't fall under the purview of our citations. That was just some general knowledge that I had.
Yeah, I'm just curious because the criterion that I would advance is what is used for practical experimentation and what has been experimentally validated. I can point you to tons of evidence of Compton scattering being validated in this manner. Using a particle representation, but
I'm not disputing the measurement. I'm disputing the physical interpretation of it that's necessitated if you use Planck's constant to give to make light a physical quantized chunk of energy rather than a wave. That's all that's in dispute here. It's not the measurement; it's the algebraic shuffling that could be done to represent the same thing with no violation of momentum conservation, because the wavelength will change as a function of the angle.
Okay. What law of physics says that light needs a medium to propagate?
I don't know.
Okay. So I think at best we would maybe have an impasse of mutual exclusivity, right? This wouldn't invalidate Compton scattering being able to be modeled as a particle, right?
What's that?
Sorry, this would only suggest a lack of exclusivity, right? This cannot invalidate the experiments that have been done modeling the photon as a particle that's quantized.
Time.
Well, it goes on to show that anything that uses Planck's constant is just equivalent to the wavelength, which is, represented through a wave. And if it's represented through a wave, then the momentum of it would be a function of that medium. So in that regard, that would be like the law of physics that, you had asked about earlier. So if it's represented as a wave, then the medium would facilitate the momentum of it. So these are fun. That's why it's like that's why Planck's constant being used in that It's like making a mutually exclusive claim over the interpretation. It's saying that, this can only be explained through special relativity using 4-vector momentum, and that's because light actually travels in quantized chunks rather than waves through a medium. So we did reach time.
Yep, it's you if you want to go.
Great. Who is you? Me?
Oh, Alan, right? Didn't you just present? Yeah.
Well, Alan went and then I cross-examined.
Sorry, I'm sorry. So it goes back to you. Yeah.
Yeah. Okay. No worries.
Oh, that's right. Okay. Yep.
Yeah. No worries. No worries. I just wasn't sure, but.
Yeah, I thought he meant me as well.
No, I keep going back and forth, forgetting that we double up in the middle there of the round.
Royal you, as they say.
Yeah.
The last piece of my presentation is just the validity of quantum electrodynamics being the basis of a wide variety of modern engineering. We've already established that there is that the development of quantum electrodynamics, what I have presented is that it is a mechanistic view that has been developed up from sound principles and modeling. So far, I think the only thing we've got is that against that is the a claimed lack of mutual exclusivity and accusation of post-diction. But as I've sort of tried to draw out, we've done a lot of experiments since then. Things have moved a long way. I would specifically cite the work of Ken Wilson in establishing the physicality of sort of what Alan would describe as maybe, adjusting the mathematics. And the reality is that quantum electrodynamics is ubiquitous as a system of modeling. This is just two examples of quantum electrodynamic effects. Compton scattering is one of them. Another one is, I'm not even going to try to pronounce that, I'm sorry, but it is an emission modality of X-rays that is extremely important for the construction of X-ray devices. But the one that I really want to talk about is the application of Compton scattering and the ability to use the formalism of Compton scattering being based on a photon. I had cited earlier the source specifically that says that the legitimacy and requirement of the photon concept of optics is never in doubt. And I support that by the fact that these principles are extensively used in radiobiology. The citation that I've provided for the purposes of this debate is specifically describing these two principles. The one that I'm going to focus on is the Compton scattering. There are many practical devices that will allow for a much better field of medical imaging than what that is available only using classical methods, using the Compton energy. Now, if the claim is that it's not mutually exclusive and you can engineer it using a classical explanation based on a wave, I would like to see it. I have never seen that demonstrated or done in an experiment. And the representation of light as a quantized photon is the basis for these imaging techniques, which are extremely powerful and useful and will actually save lives. So in addition, I just want to, again, draw us forward to the end of the 20th century and into the 21st, rather than sort of this mid-20th century period where there were significant issues in quantum electrodynamics. I would posit that those issues have largely been fixed, and QED is making numerous predictions of new phenomena on a regular basis, expanding its usefulness to many biological uses such as photodynamic therapy, bioimaging, and we continue to see advances into the present day. So this is all evidence of the physicality and usefulness of the theory.
Thank you. 2 minutes when you're ready, Alan.
All right. Well, like I said, I never disputed the measurements or usefulness of it, right? I showed that the proportional ratio that's used for the energy and the wavelength are the same. So the physicality of a quantized chunk of energy isn't required to be the interpretation. It's just as valid as a wave, and there's no contradiction in anything. So if you, that's all I got to say about that. And, like I said, I never disagreed with the measurement, just the interpretation. That's all the time I need for that.
Okay. And you then are presenting.
Yeah. Did you have anything to add on to that, Lucas?
Sorry, was there a question there, or I could add something?
No, it's just a clarification. No, it's just a clarification.
Okay, got it. Yeah. Yeah, so I mean, I would just posit that if it were if we're not the case that Compton scattering was able to be formulated in this way, it strikes me as odd that no practical applications do so.
Well, they already do so inherently when they use Planck's constant as a function of the energy of the frequency, because it's equivalent to the wavelength. So all the equations that use that are basically just using the wave equation without admitting it, so to speak, because it's an equivalence, right? It's not that it would be like a different thing. The proportional energy that's being described is equivalent to the wavelength change, and the speed of light is lambda times c, or I mean, sorry, lambda times f, which is wavelength times frequency.
I guess for me, I don't see evidence of equivalency. And in the same way that you sort of have demanded proof of physicality, I would posit the same thing back to you. And I struggle to see how light being thought of as a wave in this context. Obviously we have a duality, but our ability to actually model and represent this phenomenon from all of the evidence that I can see is dependent on the particle representation. So I see some evidence in engineering or experimentation that validates that this actually works.
So the beginning mathematical derivation, which I'll send to you here on Discord real quick. Oops.
Yep.
Just copy. Okay, one sec. I take a screenshot. All right. So they actually start with P equals H over C. So they actually start with the wave momentum, right? They shoehorn in Planck's constant in the middle of their escapades there in the algebraic shuffling. So they're getting rid of the wavelength aspect of it, but they're replacing it with Planck's constant, which is equivalent to the energy of the wavelength and the frequency. So they're not really, it's just they're shuffling in something that represents the exact same thing. And they started with the thing that I ended with. So my interpretation supersedes the leftover Planck's constant and the formalism there that they try to present it as when they're saying that this is mutually exclusive because we had to use this Planck's constant.
Okay.
Sorry, dudes, and real quick, apologies to the audience. The screen share issue is completely my fault. I should have tested this, but I should have tested this beforehand, but I did send it to Lucas who can see it. So hopefully that means something.
And where are we?
Yeah, so I guess the biggest thing here is if the contention is that you maybe could model this a different way, I might be able to accept that in this particular context, but if we're getting to the physicality of how this would work, there wouldn't be any sort of invalidation of the other side from this, right? It would only be casting doubt on our ability to measure or model a photon as a packet.
In this particular instance, it wouldn't have mutual exclusivity towards disproving what you're putting forward, right? Because I'm showing an equivalence in this particular example. To show the incorrectness of wave particle duality, we would have to discuss other experiments.
Okay, understood. Going back to this idea of light needing a medium, I think that's important. So the claim is that that's the dependency for light to impart momentum. Can you speak to that specifically? Like what is the reasoning for needing a medium to transfer that, as it were? And how does that relate to this?
Well, without a medium, how could it transfer? It's just a logical, cohesive framework. So it's just a function of the medium, like any other wave that would have momentum that you would consider a wave. So, and we are at time.
Yep, I see that.
All right. So I think it is my turn. All right, give me
Your last
second
one, right?
here.
Am I right?
Yep.
Okay.
Let's see here. So let me see what I got on the old Copenhagen interpretation here. All right, so if wave particle duality were true in double slit experiments, you would see a double slit fringe instead of a diffracted pattern, and you could introduce ambient heat to collapse that wave function and cause that double slit that no one has ever seen. Now, when you get into the modern experiment that you were referencing with the temporal mirrors, right? They have a moving medium that's representing the that's doing the continuation of the double slit experiment, and they did get a fringe pattern that corresponds to that double slit. But what they didn't show was their raw images. They showed like simulations and computer overlays of what the predicted patterns and stuff would be, but they didn't show the raw images. And I'm curious what the raw images of that would be, because if you're familiar with the quantum eraser experiment or the which way, what they do is they split up two different detectors, and they say that this is proof that light changed its course, retroactively changed its path or whatever based on the observer. But when you combine the two detectors together, it makes the same fringe pattern that's always made. And further, what you could do is you could introduce fog, and you could put like a fog machine in the lab, and when you do your experiment, you could see the diffraction pattern of the waves, and you could really know for certain if the mirrors are making that temporal measurement, as you say, that's producing that double slit fringe pattern. But you would be able to see whether or not if the light is traveling in discrete packets of energy, because then the fog won't reveal anything, or you'll see that diffraction patterns in the fog, like was done in the YouTube video. So that's it's never been exclusively shown that the fringe pattern that's necessary for wave particle duality to be true has been physically manifested. And furthermore, the idea of wave particle duality and things high and the uncertainty principle and all that is all based upon Max Born's 1925 paper, where he takes Schrodinger's wave equation and squares the solution to it, and says that he creates this probability cloud of where the electron would live and all these things. So none of that has any explanatory power, right? If you take a wave equation and that describes a wave in a medium, right? And then you go, oh, let me square that and say that the charge of the electron exists in a cloud around this area. That's not, that's like a cool expansion pack, right? But the primary material there is the wave equation that did all the work. So I think that's all the time I need for that.
Okay, Lucas, when you want, 2 minutes.
All right. So I want to get back again to this idea of the medium. What experiment establishes the necessity of such a medium, especially in relation to de Broglie waves or the wave equation as it pertains to the other side of the quantized like matter field, as it were? Like what is the medium in that context, and what physical law establishes its necessity?
Well, let's see what Schrodinger did as a response to Max Born's 1925 paper is he created an electron medium to represent all of that and show that would serve as the same process where you're like, oh, we got this momentum. How do we do that? Well, it comes from that medium that's being supplied as the function of that medium. So all you need to introduce to solve any of this is just accept that there is a physical medium, and that's it, rather than the quantum interpretation, which says that that there is no medium. It's fields of mathematics described as discrete packets of energy. So when you get down to physical properties of the medium, I would say that those are the electric permittivity and the magnetic permeability constants.
So I think that was kind of telling, right? Accepting a physical medium, but we're in that case, going back to my criteria that I established of the need to have experimentation. What experimentation in your citations that you provided necessitates on a physical law such a medium existing?
Well, classical mechanics is built on, like, is the default position, right? Your quantum electrodynamic theory is supposed to be superseding that. So you have to provide some mutually exclusive experiment that explains your interpretation of there being no medium and everything being discrete quantized chunks. What we've gone through so far is that all the equations and all the experiments can be represented through wave mechanics, wave equations, and not physical discrete chunk, and the description of physical discrete chunks and packets is not has not been shown to be mutually exclusive.
Why is there a default position in science? What establishes that? What philosophical rule of science establishes a default?
It's just based off of all the previous experimental and everything that was built upon previously, right? That was the classical framework of interpretation, right? Continuous lines of force are facilitated by a medium. That was Maxwell's interpretation, right? This was what everything was built on originally. And then QED had to come along, specifically Dirac, and he's mentioning in his memoirs as well, saying that the issue was we have to describe everything as discrete packets. We start with the uncharged electron, which is, not a physically real interpretation of anything. And then when we apply the interaction of charge to it, we have to say it's interacting with this quantized field. And that leads to perturbations in the equation, which changes the mass of everything and, leads to divergence and all this stuff. So you're trying to supersede the fluid, like a fluid medium or a real medium, and waves waving. The burden of proof is on you to supersede that. You're making the positive claim, whereas the default position was already established of how continuous lines of force work.
The topic of this debate isn't whether one is a model of reality or not, it's the physicality. Therefore, to be a default position, one would need to establish the physicality of such a medium. What is the experimental evidence that establishes your claim to default position that you are now?
Yes. So whoever measured the electric permittivity and magnetic permeability constants.
Is that in your citations?
Well, no, but you're asking me about something that I can't answer without that, because that's just what it is, right? That's common knowledge that those are the background properties of a vacuum, showing that the vacuum isn't empty, right? That leads into the Casimir effect. So it's all incorporated into the same thing. So no specific citation, but that's what it is.
Okay, that makes sense. But where is it shown that permittivity and permeability are linked to a physical medium, rather than just being properties of space itself or of the propagation itself?
Got you. Well, it's a logical deduction then. If you have impedance, what causes the impedance? There has to be something physical there. There can't be nothing. Nothing can't cause impedance. And as we went over earlier, the idea put forward that wave propagation happens as a function of Planck's constant hasn't been substantiated. So there's nothing to supersede the default position.
Right, but again, I'm not seeing a default position being established in physicality. I guess one other question I would have for you is with relation to the Casimir effect. You would accept the sort of the Casimir effect as a real phenomenon, correct? As a real phenomenon.
Yeah, absolutely. But the interpretation given doesn't supersede the classical explanation for it. So it doesn't. There's like you have a mathematical explanation for it, and it doesn't provide mutual exclusivity over the interpretation either. So even what's that?
What classical prediction predicts the Casimir effect?
Not sure. I don't have a specific citation for it. I didn't have anything.
That would get to the exclusivity, right? Do you think that there is ever within the QED position, do you believe that is the case that empty space exists?
Empty space exists? No.
Okay. Why not?
Oh, I'm sorry. Can you repeat the question?
Yeah, within the framework of QED, assuming for the sake of argument it is true for a Steelman, does empty space exist? Truly empty space exist?
Oh, yeah. Sorry, in the QED paradigm, yeah. Yeah, it would be in between the discrete packets of energy, I suppose.
Oh, okay.
Is that good? Because you know how they have like a continuous line of force, but then QED breaks it into quantized chunks, so it would be like little dots instead of a continuous line. So there would be space in between the dots. I suppose you could argue that that would be, truly empty.
But that would be below what? Do you agree that that would be below what would be observable? That the spatial scale of that would be below what's actually observable based on plot.
Well, whether it's observable or not, it's inherent to that model. So, because otherwise, the line of force would just be continuous, and there would be no way to differentiate the interpretations from the classical theory. Like the big thing of QED is that there's no medium, so there can't be a continuous line of force. It's actually made up of discrete energy packets acting on each other at a distance.
Time, by the way. Do you have any follow-up questions there?
Oh, for me, I'm at time, so
Yeah.
I didn't want to use the lack of time.
Okay. I think, is that it, or we go to outros?
Yeah, go to outros.
Okay, sounds good to me. And who's going to go first? Probably you, Lucas.
Yeah. So I think what we come down to on this debate is that I have presented extensive experimental evidence that shows that QED is a very precise theory that predicts extremely well the experimental data. Since the 80s and beyond, there has been no demonstration that that's not the case. I established that as the criteria for physicality. There has been no law or indeed any experiment put forward to establish that light needs a medium. And I want to also draw forward the Stern-Gerlach experiment, which I mentioned at the beginning, which establishes the need for discretized particles and supports the particle-wave duality. There is no known law of physics by which an inhomogeneous magnetic field would cause a splitting of a wave in the fashion that's observed in Stern-Gerlach. There is no default position in science. This is a debate about physicality, not models. And there has been no established physicality of the classical explanation based on accepting a physical medium. We have shown that the math is indeed physical. Therefore, I conclude my time on QED being a physically correct theory.
Thank you very much. Alan, you got, we're doing 1 minute. Sorry.
Yep. So in regards to the Stern-Gerlach experiment, if you interpret that as mutual exclusivity, you're attributing the spatial alignment to the inhomogeneous part of the field, which would be the weakest part. And the majority of the atom's time spent traveling through the field is done in the strongest part. So what the classic theory, what you could say equally as valid is that even if there was randomized distribution for the magnetic moments, once they align with the weak field, they enter into the stronger field, which keeps them in alignment and stops them from deviating. So it does actually make the exact same prediction. And when you get into the equation that they use to explain the Stern-Gerlach experiment, they use the entire electric field gradient and not just the weak field part of it, which is where they're framing it for the mutual exclusivity. But because they use the entire field, it can be equally shown that the difference in the strength of the x-axis and the z-axis would make the exact same prediction once the alignment starts with the weak field, and then as it travels through the strong field, makes the exact same prediction for the amount of force that's acted on. So that's it.
All righty. Thank you guys very much. I'll get some final words. Just tell people where they can find you. You can start out there, Lucas.
Yeah, so my server is Globe Gangsters. You can also typically find me on the Twitter Spaces, and I'm fairly active on Twitter. My Twitter is just Mordwan42, so you can find me there. I do sometimes hang out on some other servers, Earth Awakenings and Medicinal Mass Media, but yeah, my main gig is Globe Gangsters, and we're trying to build a fair platform for open discussion. So I would appreciate anyone who wants to drop by, no matter what position they hold on any issue. So
excellent. Thanks for being here. And Alan, go ahead.
Nice. So we do weekly presentations over on Ether Cosmology on that Discord. And so you can check my YouTube at @space_audits for weekly presentations. We do a lot of research over there. So, check us out. And thank you, Mordwan. This was an awesome debate. I had a lot of fun. I'm sure it was very dry for the audience, especially with no visualizations. But I had a lot of fun, and thank you. I appreciate it. And thanks for hosting, Jared. Much appreciated.
Anytime.
Likewise, this was a lot of fun, and I appreciate what you bring forward, Alan. And I think that we could have a lot of interesting and mutually beneficial conversations in the future about the, in particular, things like the Compton scattering and how it could be modeled with a wave and other things of that nature. And one of the things I wanted to close is, if I could just say one last thing, if you don't mind. One of the things that I think when we talk about Casimir and 0-point energy in the vacuum, and indeed the state of general relativity, I think that there's an opportunity for a construct of the ether to come back in a meaningful way. So yeah, I think that it's a fruitful area of discussion, and I thank you for what was a really awesome and civil debate back and forth. So thank you.
Yeah, it was awesome. Good time, guys. Thank you very much. It was fun. If you want to do it again, let's do it again. And I don't see, let me just check Rokfin real quick. I don't see any super chats. Thank you guys for the memberships. Justin Johnson gave away a bunch. And AJ Bateman joined a couple other people, but let me just check Rokfin. No, none there either. All right, so no questions for you guys. We'll get some more next time. Appreciate you being here. Guys, tomorrow we've got my Jeranism show. That starts at 3, so be here at 3 tomorrow for that live show. And I believe that is it that I know of, yes. So I remind you guys, do your own research. When you do, you'll never again believe all the bullshit you've been taught. Till next time, this has been DEBATISM. Thank you very much to Lucas and Alan. Peace.
Peace. Yeah, Lucas.
Yeah, it was nice just hanging out. Now go and hit the bell. Share it with the homies so that they could grow as well. They missing out. Jaren leaves no doubt. If you know what we bout, it's never for the clout, don't fuck around. Hey, not for the clout, that's too cap, we calling them out. Balls get flat when you cover the route. Jeranism all in your mouth. Truth gets lost like all in the couch, but it's time to get up and make them get out. Uncover the route. Jeranism, we are the crown. Telecasting worldwide, check the globe is falsified. Space is spinning DFI, all just scientism lies. Telecasting worldwide, check the globe is falsified. Space is spinning DFI. All just scientism lies.
Who this be? What he about? You stay spinning, he stand out. About flat earth, it's flat out. He's still standing when you pass out. Globers pound, screaming, shout. He can turn you inside out. Yeah, surface deep, he's felt throughout. And he stay grounded, you spaced out.
We gotta run nowhere when we come fact check your facts and match your data. Concept is too abstract, what matters? Trying to tune in, but the note get flatter. Tell me I'm flattered. Flatter than pancake batter, now we landed. Jeranism, I'm your captain. Speaking, telecasting worldwide. Check the globe is falsified. Space is spinning DFI, all just scientism lies. Telecasting worldwide. Check the globe is falsified. Space is spinning DFI, all just scientism lies. You know equations to the things you make the symbols for, but ain't really explaining what the symbols for. They try to teach you things against the things we taught before. No point in arguing now, they don't wanna talk no more. Okay, got a bite of the truth and now it's certain. That's what life look like when your mind is certain. Okay, got a bite of the truth and now it's certain. That's what life look like when your mind is certain. Thanks to the east side, thanks to the west side, thanks to the north side, way down to the south side. Thanks to the east side, thanks to the west side, big ups to the north side, way down to the south side. Telecasting worldwide, check the globe is falsified. Space is spinning DFI, all just scientism lies. Telecasting worldwide, check the globe is falsified. Space is spinning DFI, all just scientism lies. Telecasting worldwide, check the globe is falsified. Space is spinning DFI, all just scientism lies. Telecasting worldwide, check the globe is falsified. Space is spinning DFI, all just scientism lies.